Okay, so I'm going to run through this, trying to be really quickly. We're just going to do this top part, the part that I have showing on the screen right now. We're actually not doing the whole page, mostly just so that you can fit this little bit in today. I'll finish the notes tomorrow so you have time to actually work on your worksheet and get it turned in one class period. Okay, so concentration means the measure of the amount of solute. Remember, that's what you put in. So you put this in. The solvent is the liquid that it's dissolved in. Okay, if I have more solute dissolved in a solvent, then it's more concentrated. So if someone says I have a really concentrated solution, it means there's more of that solute dissolved in it. So the first one, now I'm forgetting the term, goodness. This is why I had it pulled up. Pretty sure it's just concentrated and dilute. Yes, I don't know why. Second guessing myself. Okay. So the first one where it says it contains a relatively large amount of the solution, we're just going to say it's concentrated, what I just said. So if you have a concentrated solution, concentrated. Man, that was awful. My board is just getting worse and worse at looking okay. Concentrated, right? The next one is if it contains not a lot. So I'm diluting it. So if someone needs to dilute their product before they can use it, like a lot of times we can't use the acids we use in class until it's been diluted. That just means that it has more liquid in it, has more water in it than the solute. So it has less of that solute dissolved in it. So concentrated versus diluted. The molarity can tell me how concentrated something is. So molarity has that word mole in it. So it does have something to do with moles. You're only going to have to do one-step mole problems in this, so it's not bringing it fully back, but moles do come back a little bit with molarity. And knowing the amount of moles that I put into something, that is the solute. How much am I measuring out? How much am I measuring out in grams to dissolve into the solution? So it's the number of moles, hence the name, molarity, number of moles of solute, what you are putting in, dissolved to make 1 liter of solution. So we're, instead of dealing with things like grams, we're doing liters because we're dissolving it into a liquid. So liters is a liquid volume kind of unit. All right, now your formula is I have moles of solute divided by liters of solution. Really easy. You just take the two numbers and divide by each other. That's a molarity. That's the easiest one. It's not hard. Or maybe they don't give me the moles, they give me the mass. So I'm going to have to do that one-step problem first. I'm going to do a mass to mole conversion, which is a one-step problem, and then divide it by liters. So it's going to really kind of be 2 steps, but I'm really just going to solve it in 2 different problems. So a little bit harder, but both of them are really not that hard. Okay, so we're going to go through this problem. Really the best way to learn it is just to do it. So I have 2.5 moles of glucose. Glucose is sugar. So they're saying I'm going to mix some sugar, 2.5 moles of sugar, into water. And the amount of water I have is 1.5 liters. So that's less than like a 2 liter of Coke. Okay, so a little less than that, 1.5 liters. And they want to know what's the molarity, which really means what is the concentration? How concentrated is that solution is what molarity is. It's trying to figure out how much of that solute has been mixed in. So for this formula, it's going to be this one, right? That first formula, I have been given moles. So if you're given moles and you're given liters, you literally just use that first formula and divide them by each other. It says the moles go on top, so I put 2.5 mole of glucose on top of 1.5 liters, this big L, divide them by each other, and that will be the molarity. So I have 2.5 divided by 1.5, which is 1.67, and the units didn't cancel, so they're both there. So it'd be mole over liter, which is the unit for molarity. So that is how much moles into liters. Now, if I needed to measure out what that is in grams, I could. I could take my moles and I could do my one-step conversion to grams and know how much to weigh out. Okay, last type of problem is they say a saline solution contains 0.9 grams of NaCl, which is salt. So now we're making some salty water. We have a 110 milliliter solution. You know what? I'm not going to make y'all do milliliters, so I'm just going to convert that real fast. 110 milliliters is 1,000 milliliters for every 1 liter. So I take 110 divided by 1,000. It's actually 0.11 liters. So I'm just going to go ahead and change it 0.11 liters. There you go, of solution. What's the molarity? So on your worksheets, I'm just gonna give it to you in liters. You're only gonna have to convert the moles. So I have grams given to me and liters given to me. So that means I can't use this first formula like I did here. I'm gonna have to use this second formula. All right, I'm gonna use that second formula because I was given grams, which is a mass. So I'm gonna have to get my mass into moles first, and then I can go back and just do my moles divided by liters problem, my normal easy one. So I take my 0.9 grams of NaCl, and I need to convert it into moles so I can get molarity. So I'm gonna get rid of grams of NaCl on the bottom, and I'm gonna go to mole of NaCl on top. Remember from back in our mole days, whatever will always with mole was 1. Okay, so this was stoichiometry. This was just on your review for the CDA. Always is 1 if it's a mole to gram question. And what was grams was always molar mass. Still is. Okay, the molar mass of sodium chloride I actually have memorized. It's 58.44. So we've done that one enough that I know it. But you take the mass of sodium, which is 22.99, and you add chlorine, which is 35.45. All right, so now I take top two numbers, 0.9 times 1 is still 0.9, and divide by 58.44. And I get the mole to be 1.015 mole of NaCl. So now I'm back to the point that I have mole given to me, or I've solved for it, and I have liters. So now I can do that original formula that we did in the first problem, just moles divided by liter, and that's molarity. So I take my 0.015 mole, I divide by the liters given, 0.11 liters, and this will be molarity. I'm gonna move that arrow up. There we go. So 0.015 divided by 0.11 is equal to 0.14 mole divided by liter, which is the unit for molarity. That is the concentration. There we go. So that's all we're gonna do today. We're gonna practice how to do the dilution problems tomorrow, which are also pretty simple. So the only math in this unit is just dividing, pretty much, multiplying, dividing. Okay, need to stop it. If it would let me. Why won't it? There it goes.